Welcome back. This is lesson 7.3 journal. Write algebraic expressions. I will be able to understand and write variables to represent unknown numbers. I will be able to model and write algebraic expressions. To represent real-life situation using variables. Okay, we've got quite a bit of vocabulary today, so you'll need the first page of the vocabulary and definitions for chapter 7. Alright, the first vocabulary word is a variable. A variable is a letter used to represent an unknown value. An algebraic expression, we already learned what an expression was and a numerical expression, but an algebraic expression is an expression that contains numbers, variables, and operations. So it takes a statement from real life and turns it into math language. So example, Jane had some money and then earned $5 more. So that expression, I don't know how much money she had to begin with. So we use a letter to represent that. So I'm going to call it M for money. So an expression would be M, and then earned $5 more, so earned would be a positive thing, so it's adding. And what did we add to it? 5. That is an expression to represent what happened here. We know she had money, and then she added 5. We just don't know what she started with. That's why we're using M to represent it. Okay, these are some review, but very useful to know. A product is the answer to a multiplication problem. Sum is the answer to an addition problem. Quotient is the answer to a division problem. Difference is the answer to a subtraction problem. Alright, so knowing that, we're going to talk about modeling algebraic expressions. So these are known as algebra tiles. Okay, you'll get used to drawing them a lot, especially in 7th and 8th grade. But a long rectangle is going to represent x. So this equals x, or any other variable. And then little squares are going to be equal to 1. So if I want to model the algebraic expression 3x plus 5, I need 3 x's, or 3 long rectangles, so there's your 3 unknown numbers, but I know I have 3 of them, plus 5. So I just draw 5 squares. So there's 3x plus 5. Okay, this one, the way it's written, 2n, so 2 variables. So I draw 2 long rectangles. (2n) plus 3, so this would be 3 of the little squares, plus 3n. Here's an example of that expression. Now this one's a little different. We have grouping symbols, so that means I need to make groups. This number tells me how many groups I'm going to make. So I need 2 groups of what's inside here. So to make a group, we're going to draw 2 circles. So there's our groups. Now in each group, so there's the 2 part. In each group I need a W, so 1 variable. There's 1 in this group and 1 in this group. Plus 3, so 1, 2, 3, 1, 2, and 3. That's all there is to modeling algebraic expressions. Now, I want you to be able to turn real-life situations into algebraic expressions. So we're going to talk about word clues for operations that we might see. So when we're adding, there's quite a few words that could help us. Okay, the go-to is sum, more, if we're getting more, increased by, in addition, well, that one's pretty obvious. Okay, let's think about some subtraction words. Difference is a big one. Minus. Left. Remaining. What are some other words that come to mind when we're subtracting? Takeaway. Decrease. Okay, multiplication. If we just have the word of, not sum of or difference of, if it just says of, that's usually a multiplication problem. Okay, product. Times. Okay, some special ones are like twice. Usually means 2 times. Or triple. That's another timesing word. That one's special though for 3 times. Okay, division is quotient. Separated evenly. Oh, another good one for multiplication would be groups of. Okay, if you can think of any other ones here. Oh, combination's a good addition word. Combine, we'll just say combine, because you're putting things together. Together, that's another one. Alright, now here it says write an algebraic expression for each word phrase. 4 more than J. Or sorry, than M. So I'm adding 4 to M. The difference of 15 and X. Now this is important because difference is a subtraction word. This came first, this came second. So that means I'm taking 15 and minusing X. Okay, the sum is an adding word. And what are we adding? 6 and D. The quotient of P and Q, okay, quotient is another one that order matters. So this would be P divided by Q. We could also write it P divided by Q. The product of 6 and Z. That means 6 times z, or we can just write it with a variable. We can just write 6z's because it means 6 of these. So this and this mean the same exact thing. We just don't have to write the times symbol. Now this one says twice the sum. What are we timesing by 2? The sum. So if I just write 2 times 4, is that twice the sum? No, that's just twice 4. So I need to do 2 times the whole sum. Now sum means adding. So what am I adding together? 4 and y. It said twice the sum. This way I'm timesing the entire addition problem by 2. Alright, some more real life examples. Define a variable and then write an expression for each situation. So to define a variable means just pick something and tell me what it represents. So here we have $20 more than Carlos. Well, I don't know how much Carlos has. I'm going to say C. We can call it whatever letter we want. We have 26 to pick from. But C, and what does that represent? That would represent Carlos's money. Now, how do I say $20 more than Carlos? I take Carlos's money and I'm going to add 20 more. Simple enough, but if I just wrote C plus 20, you wouldn't know what I was talking about. If I tell you what C is, now you do. Next one, triple Amy's age. Okay, I'm going to say A for Amy's age. Now what did I do with Amy's age? I tripled it. That means timesing it by 3. So 3 times A. Triple Amy's age. 5 inches more than twice Jordan's height. So what's being multiplied by 2? Jordan's height. I don't know what Jordan's height is, so that's what's going to be my variable. So I'm going to use J. So J represents Jordan's height. Now what do we know about it? Twice Jordan's height and then 5 more. This has 2 things going on. So twice his height, so that means I got to do 2 times J, but that's not it. 5 inches more means I have to also add 5 to that. 5 more than twice Jordan's height. The combination of Maggie's and Joe's points. Well, I don't know what Maggie got and I don't know what Joe got, so I have 2 variables here. I'm going to say M for Maggie's points. And I'm going to say J represents Joe's points. Now what did we do with them? The combination, that means I'm going to take Maggie's points and I'm going to add it to Joe's points. There is an expression. There are not even any numbers in there, but until I know what Maggie got and what Joe got, I can't give you any more than that. But that's what's mathematically happening. Alright, here says write a word phrase that could be represented by each expression. You write your own thing. What could T represent? And then write me a phrase. That is what you need to do on your own. After you've done that, rate yourself on this concept 0, 1, 2, 3, or 4 and turn it in a Google Classroom.